Hello, welcome. My name is Frances. I'm an academic advisor here in the College of Engineering at UC Santa Barbara. Thank you for joining us. My goal today is to talk a little bit about what it's like to be an undergraduate student here at UC Santa Barbara in engineering. I'm not an admissions officer, so we will not be discussing admissions requirements, but thank you for your interest in the college and thank you for joining us. If you're not familiar with UC Santa Barbara, there are 3 colleges for undergraduate education. There's the College of Engineering, the College of Letters and Science, and the College of Creative Studies. So while UCSB has around 20,000 plus undergraduate students, the College of Engineering actually is on the smaller side with around 1,700 students. So I'll go ahead and remove my video now so we can go through the slides, but thank you. It's nice to meet you all. So as I mentioned, there are about 1,700 undergraduates in the College of Engineering. We offer 5 majors. You can see them on your screen. I will talk about each of the majors and some of the research happening in subsequent slides. You might notice that there is not a bioengineering major or a biomedical engineering major. And now that bioengineering research is certainly being done on this campus. It's very interdisciplinary and very collaborative, but it is not an undergraduate degree here. There is a graduate program, but again, there's not going to be a wide selection of courses to meet that educational interest for a student. Students who are interested in biomedical engineering or bioengineering certainly can get some experience in research. There certainly are some core courses that are offered and would be relevant, but it is not an undergraduate degree here. It's very important at the time of applying to UCSB that if you are interested in the College of Engineering, that you select one of these majors as your first choice in order to be considered. Now, while it is a wonderful thing that we are on the smaller size, it means lots of good things, good opportunities, good ratios between faculty and students, lots of opportunities. It does mean that it is not easy to switch into the College of Engineering. So if you apply to the College of Letters and Science, attend UCSB, and then decide you'd like to be an engineer, there is a process to try to pursue that, but it is definitely not a guarantee. The courses are really the spaces offered for students currently in the majors. Similarly, if you're already here as an engineer and you decide you'd like to switch into one of the other engineering majors, that's not a guaranteed process either. We're very small and cohort based. So I encourage folks to look at each of these disciplines, do some research, figure out what area they're most interested in, and make sure upon application that they apply first choice to that given major. If the chancellor here at UC Santa Barbara, if you're not familiar, is a mechanical engineer, and they teach one course every year. And then our associate dean of undergraduate studies is also a mechanical engineering professor who also teaches 2 courses a year. So I'll talk a little bit about our majors. They are structured and sequential, which is probably no surprise. It is fairly typical and easy for a student admitted from high school to graduate in 4 years. We offer a 4-year guide that we call a grid. You can see a sample on the screen that indicates to student how they would move through the major. Each of the 5 majors has a grid. Now, students who come as transfers, most of our students come directly from high school, but every year we do have a small incoming cohort of transfer students. You'll be given a customized grid because some of the majors, sometimes the prep isn't available at your previous institutions, and so you don't necessarily just come in at the halfway point. So students who attend another school first, a California community college perhaps, they'll be given a custom plan. Students often ask if they have transfer credit from what that they did simultaneously in high school, whether that's AP or IB exams. Maybe they took a college course or 2. Can that help them graduate faster? In general, the answer is no. It will create potential pockets of space to incorporate more enrichment or perhaps a minor, or sometimes with limited success, a second major in the College of Letters and Science. But most of these courses are only offered once a year, and they're very prerequisite driven. So you can't necessarily just speed through the curriculum. The other thing is there is a required capstone in the final year, again, that is prerequisite driven. So that's why it's not easy to graduate in less than 4 years, or not possible for 4 of the 5 majors. Computer science major does not require a capstone, so it sometimes is possible to graduate early, but it is not, again, not a guarantee. Our curriculum blends the theory with the practice. We like to say it's kind of close to a 60-40 split, perhaps a 60% emphasis on the theory, maybe a 40% emphasis on the hands-on. While certainly some of that hands-on really does come in the junior and senior year, there is early exposure to the hands-on as in the majors earlier in your career. So certainly some of the labs, both in chemistry and physics, and the mechanical engineering students, for example, have to take a machine shop class where they get experience using some of the machines that they'll later need when they do their junior design and their senior design projects. And then there certainly are, for example, there's a circuit fab class that students will take. Both the computer engineers and the electrical engineers take a year of circuits with lab early on in one of the electrical engineering classes. There's a digital logic design course. So the hands-on is sort of scattered throughout the curriculum, culminating in the senior design and capstone projects. When you get a moment, you can look up the College of Engineering UCSB capstone, and there's a website with several projects from the last several years. And this is really the culmination of putting everything into practice. They're team-based projects, often in partnership with a local company, so solving a real-world problem. And then there are some that are a bit more student interest based. So, for example, in 2023, one of the recent projects was a mechanical engineering project where they were modifying exercise equipment for a Paralympic athlete. So weight machines are often hard to adjust if you are in a wheelchair or perhaps have a mobility issue that limits your fine motor skills. And so this project was using a guided pin to adjust the weight and a button to adjust the height. Another capstone example was a little bit more student interest based, called AMPed. This was an electrical engineering project where they were working on a pocket-sized amp using a digital signal processing and the natural resonance of a guitar to amplify sound. So conventionally, you'd have an amplifier and a speaker and then an effects pedal born. And this all condenses it down to a device that you actually could hook on the back of a guitar and a box on the strap. So those are a couple of examples of this capstone project. And then these majors do allow students to prepare equally for industry or for graduate school. Many times people will ask us for some stats on that. We don't require our students to tell us what they're up to post UCSB, so the stats are hard to nail down, but we do know students equally are prepared and go in both direction. For example, some of our 2023 outstanding students would be students who graduated in 2023 and had the highest GPA in their major. I think they're good sample size. The top chemical engineer was going to the Bay Area in California to work in the biotech industry. Our computer engineering top grad did undergrad research and probabilistic computing, and then they're headed off to UT Austin for a PhD. Our top CS student was going to industry as a software engineer. The top electrical engineering student also going to industry. And then there was a tie in mechanical engineering, 3 students who received the top grades, 2 of them going to industry, another going into a PhD program in controls. And so just kind of an interesting mix. And I think that reflects kind of what our student population does. You'll notice that there is some room for interdisciplinary exploration. I kind of talked earlier about how sometimes students come in with transfer work that might clear some of their requirements. And as I said, rather than necessarily allowing a student to graduate early, it really will free up space in their schedule where perhaps they might not need to have as heavy of a load in a given quarter, or they can use that for exploring their interests. The GE program is pretty comprehensive here at UCSB, and so that's one way that students can do some interdisciplinary exploration. But also, as I said, if a student has a lot of credit clearing out maybe math or some of the GEs before they get here, then that might leave them room to perhaps explore something like a minor, which is about half the size of another major. In some cases, it may be possible to add on a second major, although I will note that you cannot major in 2 engineering disciplines. So now I'll turn my attention to each of the 5 majors, more to give you a little bit of an idea about the major, the size of it, and some of the research going on. So chemical engineering is the smallest of our 5 majors, close to 200 students. The picture on the screen is from Michelle O'Malley's lab. She's one of our chemical engineering faculty whose work looks, it was kind of a little bit more on the bioengineering side, actually looking at some of the properties of some plant material and the gut microbes in animals like cows and sheep that allows them to digest and some of the plant materials in a different way. You can see on the screen some of the big areas of interest and expertise that our faculty research falls under. Now, these are not not something that a student can specialize in and have on their degree. It's just rather to give folks an idea of what our faculty here, where their research lies. Chemical engineering, I think a lot of folks don't quite know how it differs from chemistry. And so one of the very first Chem E courses, Chemical Engineering 5, taken in a student's first quarter, it kind of answers that question. So they all begin with the idea of how to kind of conceptualize and visualize the making of a potato chip, how to go from potato to chip, and then how to kind of put that at a large scale process. And I think most of us could visualize that, those steps. How do you make them continuously and then maybe at scale? And so they think through that process, and then they switch to the same process to a commodity chemical like ammonia, which would be used in fertilizer. So if you think about the basic pieces of equipment that you would need to build a chemical plant, that's really closely aligned with the chemical engineering curriculum. So in this example of ammonia, you would need a reactor to take the elements to make the NH3. So there are 2 chemical reactions courses. You would need to separate the final mixture to sell the pure version of it. There's a separations process class. And then of course you would need to design the pipes and the compressors, and you would need to control the process. And so these are all topics that are featured in the chemical engineering curriculum. Some interesting research that's going on as of late. Professor Susanna Scott, she does work in plastics. They are trying to create a higher quality plastic molecule that then can be more likely to be recycled while still maintaining quality. So one of the barriers to recycling plastics is that the quality of the end product is usually far inferior to the quality of the original product, which really de-incentivizes recyclers from investing time and resource. So they are looking at trying to create a higher quality plastic molecule that wouldn't kind of degrade as much. The next major is computer engineering. There are close to 300 majors, and computer engineering really is related to electrical engineering. Computer engineering here was founded as a collaborative program between the electrical engineering and the computer science departments. So it is not really a bifurcated department, but rather it's the intersection of both of them, understanding the software and the hardware. And that's very important in today's world. It's a highly desirable skill set. So we have a series of required courses, and then students, there's a large elective section in this major where they can kind of choose to have an emphasis on one or the other, but all students in this major will go through the basic programming classes and the basic circuits and hardware courses as well. So you can see some of the larger areas of expertise on the screen. And again, some of these also really kind of an overlap with topics in computer science and in engineering. One of our recent graduates in 2023 was a computer engineering student who has been able to do research in Professor John Balkin's lab in computer architecture, but they also interned twice for Google. They worked on the back end of a new carousel on Android Google Maps one summer, and then the next summer they worked as a software engineering intern under Google Cloud to develop machine learning tools for one of the cloud platforms. So it's another example of a student kind of equally being prepared to go into research or graduate school. The next major is computer science. This is the largest of our 5 majors, close to 600 students. Computer science is in high demand right now. Now, this certainly is the most flexible in terms of the 5 majors, partially because it is larger, but as many of the courses happen to be offered more than once a year, which does make it a little bit easier to progress through the major, a little faster potentially. And this is the only one of the 5 majors that does not require a capstone. While there is a capstone project available, it is not required. Now, our computer science program uses C++ as the language of instruction. Many universities will teach with a variety of languages. Some focus on Java, some Python. We happen to choose C++. This is a language that enables programmers to manually manipulate memory and in many ways kind of work a little bit more on the back end of things. And then from that point, it's much, much easier to pick up all of these other languages. UCSB curriculum offers a very good foundation in computer science. We are very systems oriented. You'll notice the big areas of expertise and research on the screen. And we do not have a big emphasis on video game design. Certainly there are some faculty who might have an interest in that or teach a course here or there, and certainly some of the foundational skills are taught, but that's not an emphasis that we teach here. Interesting things rather in the news recently, UCSB faculty have been chosen to lead an NSF-funded research institute for next-level AI-powered cybersecurity. So that's relatively recent news and something you may want to check out. It's going to be called the Action Institute. Next, we have electrical engineering. You can see the big areas of interest and research on the screen. One of the things at the most basic level, EE is an outgrowth of applied physics and math. So if you love physics and math and want to apply them to real-world examples, EE might be for you. UCSB electrical engineering is known for their expertise in heterogeneous semiconductors. So rather than just so semiconductors are components in electronic devices, generally silicon-based. In this case, many of our faculty in their research are looking at materials that have properties to emit and absorb light better than silicon. So they're harnessing those materials for use in photonics, which is kind of the next gen of electronics. One of our professors, they are working on some circuits that will allow for a faster and more efficient data transfer. So you can look up Professor Chow's work group. And some student feedback. One of our recent graduates in spring 2023, their feedback on the curriculum, they were noting how much of the intro material shows up again. So for example, first quarter EEs take ECE 3, which kind of a programming class that includes the concepts of signal processing. So relevant topics like the Fourier analysis show up in circuits, image processing, photonics, and more. Next, we have the mechanical engineering major, close to 350 majors. You can see the big areas of interest on the screen here. Some of the controls stuff is in mechie as well as electrical engineering. You can see the picture on the screen is actually from one of the robotics classes. The student project at the end of the quarter is to build a little robot to navigate a course. So it's a picture of that on the screen. And we don't have a particular emphasis on aerospace engineering, although the major itself, the topics will provide the basis that a student needs to go into the aerospace industry, and certainly many of our students do, but it's not a particular focus here at UCSB. Some really interesting things happening in robotics, especially soft-shelled robotics and jump mechanics. So you can look up Professor Elliot Hawks's research, and then also kind of on the nanoscale, microscale engineering, and then also a little bit of the bioengineering. One of our professors is doing some work looking at kind of mimicking a tumor cell. They were looking to kind of give a 3D version of a cell, and they're looking at the cells that contribute to breast cancer. Our engineers do study abroad, so we'll turn a little bit now to enrichment opportunities. The University of California has a study abroad program, multiple places in the world, lots of programs that could be for, most of our students go for a quarter, generally third year of their fall quarter, and take curriculum that matches what they're doing here at UCSB. There also are research programs in the summer abroad, going abroad to learn a new language, or even interning abroad. I just talked to an electrical engineer who spent summer 2023 in Prague interning at a company there. So we would encourage students to keep that in mind. It is a possibility, even with a rigorous curriculum, it is a possibility. We encourage our students to get involved. There are student chapters of the 4 big professional organizations. This can be not only a great way to meet other students who are ahead of you in the curriculum, because you are very cohort-based with your incoming class. But these are networking opportunities. They'll sometimes bring companies on campus to give networking opportunities, seminars, and then they also have some enrichment opportunities of skills. So for example, Institute of Electrical and Electronics Engineers, for some of their lab members, there are several projects like Arduino projects that the student can access. They teach soldering classes, that type of things. So it's a really great way to kind of amplify some of your skills as well. And then this is a small list of some of the campus clubs and groups. While UCSB has over 500 registered student orgs, here's a list of some of the more STEM oriented ones. And so some of them are united around a particular interest, like Engineers Without Borders. It will be students from multiple majors. There's also students from all majors who identify with a common background, and so there are support there. Students, SWE, Society of Women Engineers, is active. There's also NSBE, the National Society of Black Engineers, and so that will be students from all 5 majors. There's the Data Science Club, so we'd encourage students to find their fit. This also helps students kind of network, but find an additional community at UCSB. I'd like to point out a bit about internships and careers. As I mentioned, our degrees really prepare students to go into grad school or into industry, and we would encourage students to pursue activities to prepare them for both. Partially, you never know what sort of direction you may think you want to go into industry, but a research experience may change that, or vice versa. We partner with the Career Center, and so you can see one page of a calendar of events that's coming up for this fall quarter. And so they're bringing companies to town for some info sessions. There's some networking meetings, and then the UCSB Fall Career Fair. So we also partner with the Career Center, and I think that that's so helpful because they'll also offer sessions on how to navigate a career fair, or how getting your resume reviewed, prepping with a pro. So there are some companies, some industry professionals that will be giving tips on networking, on interviewing, on resumes. So we would encourage students to check those out. We also encourage students to get involved in undergraduate research. Here at UCSB, I think the stat is more than 50% of the undergrads will have the opportunity to be take the opportunity to be involved in research before they graduate. It really is fairly simple, and usually it really is just an ask. Now, there are some programs designed to help support students with that. So for example, there's a directory of faculty with ongoing research programs called FRAP. That might be where a student gets started. It may be in an affiliated field. When a student gets to the point perhaps of doing their own research, there are some research grants that they can apply for, IRCA, and then a specific one for transfer students, the TSRA, that it really mimics the grant writing proposal. So they have a budget, they have a letter of support, they have an abstract, and so it's a really great experience. And then once they receive a grant, they also at the end have to present in a colloquium. And the Materials Research Lab has some research programs in the summer and year, both domestically and internationally. And then the Center for Science and Engineering Partnerships. So if a student is interested in getting research experience, it is available. UCSB in general has a focus on undergraduate education. The number of undergrads far outweighs the number of graduate students, which means that labs need help. And so there are opportunities for undergrads to to get started. And again, we would encourage students to try both. UCSB offers a combined BS-MS program in the majors that you see on the screen. So for a student who starts here as a first-year student, you do not need to apply for this when you're applying for UCSB. Generally, in a student's third year, you would make your interest known. For some of the majors, like materials, you do have, or the MS and materials, you do have to take a series of prep courses, but and then you would apply generally at the end of your third year. You start graduate coursework in your fourth year, and you stay one extra year to finish the master's. These are wonderful programs, and some of them are project-based. So as with all things graduate school, it's important to check in with the faculty if this is of interest to you as a student, but you can see the options available on the screen. We encourage you to stay connected. Usually when there's the junior and senior design in the spring, there'll be posts from that on our Facebook, so we encourage you to stay connected. If you have any questions about admissions has several presentations about the admissions process. Students who are applying as transfer students from another institution, there is a series of required courses that must be completed, so really take a moment to check out admissions but do stay connected, and if you have any questions, please feel free to send us an email. We thank you for your time.